When we look up at the night sky, we see a picture made up of a small number of cosmic objects. All of them, including stars and nearby satellites, are made of visible matter and can be studied from the Earth. At first glance, an ordinary person may believe that all of the substance from which these bodies are composed is the fundamental matter of our world. However, this is not the case, for better or worse. What we see around us is only a small fraction of the total number of elements that make up our world, and the majority of it falls on something that is even inaccessible to our gaze. Specifically, a mysterious substance known as dark matter. Dark matter, in general, is a hypothetical form of matter that cannot be observed directly. It is thought to contain the majority of all mass and energy in the universe, manifesting itself only through gravitational interaction. This concept was first introduced to explain the problem of hidden mass in some galaxies, and it has since become deeply embedded in our science. Dark matter's composition and nature are still unknown. The most likely candidates for the role of its particles are thought to be hypothetical WIMPs, which have yet to be discovered despite active searches. The first prerequisites for the search for dark matter appeared in 1929, following Edward Hubble's discovery of the red shift, which revealed that the universe is constantly expanding. One of the questions that piqued the interest of researchers at the time was how long this process would last and what role invisible substances might play in it. This curiosity stemmed from the fact that the gravitational attraction acting between individual parts of the universe tends to slow the scattering of these parts. The outcome of this breaking is determined by the universe's total mass. Gravity will gradually stop the expansion if it is large enough. As a result, the universe will collapse to the point where it first began to expand. However, the opposite outcome is possible if the mass of the universe is always less than the critical mass. The expansion will continue indefinitely in this case. Until the 1970s, the second outcome was widely accepted, and the most likely forecast for our universe was thermal death, that is, a state of the system in which nothing could ever happen. The only solace was that the universe would not reach such a state for hundreds of billions of years, so humanity does not need to be concerned about this bleak prospect just yet. But what about unidentified dark matter? Scientists quickly realized that the true mass of the universe far exceeds what can be called visible, and that it may already be close to or equal to critical mass. Despite the fact that the presence of dark matter was never experimentally proven, the possibility of our universe collapsing did not escape the attention of scientists. The next significant evidence for the presence of this mysterious component came from simulations of the process of galaxy formation, which began approximately 300,000 years after the Big Bang. These calculations revealed that the gravitational attraction that acted between the flying fragments that arose during the explosion of matter could not compensate for the kinetic energy of the expansion, and the matter simply should not have gathered in the galaxy that we see today. This problem was known as the galactic paradox, and it was considered a serious argument against the Big Bang theory for a long time. The next significant evidence for the presence of this mysterious component came from simulations of the process of galaxy formation, which began approximately 300,000 years after the Big Bang. These calculations revealed that the gravitational attraction that acted between the flying fragments that arose during the explosion of matter could not compensate for the kinetic energy of the expansion, and the matter simply should not have gathered in the galaxy that we see today. This problem was known as the galactic paradox, and it was considered a serious argument against the Big Bang theory for a long time. The familiar world, seemingly studied to the smallest detail, turns out to be only a small part of what the universe actually consists of, and our entire visible cosmos is just a screen for a vast nothingness. The general theory of relativity, in one way or another, clearly connects the rate of expansion of the universe with the average density of matter contained within it. Assuming zero average curvature, the density of space should be 10 in minus the 29th power of grams per cubic centimeter. However, the density of matter visible to us is approximately 20 times lower. Dark matter and dark energy are most likely responsible for the missing 95% of the universe's mass. If the density of the universe is indeed equal to critical, this cannot be a coincidence, but rather the result of a fundamental unexplored property of our world that we have yet to understand and comprehend. What do we know about this 95% of the universe's mass today? Unfortunately, very little. However, we can already conclude that dark matter most likely exists. Their peculiarity is that they almost never manifest themselves in interaction with matter, and thus they can be referred to as the true invisible matter that is extremely difficult to detect. Their mass should be tens of times greater than that of a proton, but the search for these particles has been ongoing for over 25 years. If such particles exist, the Earth and Sun, in their orbit around the center of the galaxy, should pass through a rain of them. Even though the wing has extremely weak contact with other particles and has little chance of interacting with an ordinary atom, it is still one of the methods used today. The WIMP search is based on the assumption that, over billions of years, various astronomical objects should have captured WINEs, accumulated them in their centers, and eventually generated a stream of neutrinos. Attempts were made at underground and underwater neutrino detectors on our planet to detect excess neutron flux from the center of the Earth towards the Sun. However, they have yet to yield a positive outcome. A particle accelerator, such as the Large Hadron Collider, could help in the search for WIMP. Scientists believe that by rapidly accelerating one particle and colliding it with another, we can expect the birth of pairs of other particles and antiparticles, such as WIMP. In some form or another, our world most likely contains 95% of something about which we know very little. And everyone's reaction to this fact will be different. It may cause anxiety, which always comes with meeting something unknown, or it may cause grief that the long and complex path of developing a unified theory describing the properties of our world has resulted in statements that most of the universe is hidden from our gaze. Most physicists, on the other hand, are ecstatic. As our science has demonstrated, all of the mysteries that nature posed to humanity were eventually solved, and each of them brought completely new knowledge and concepts that people were previously unaware of. Without a doubt, the mystery of dark matter will be solved someday. And if this happens in the near future, you, dear subscribers, will be among the first to know. Each new video on our channel necessitates a thorough immersion in the chosen topic, and you can help us improve this process by leaving likes and comments below the video. Also, I'd like to thank everyone who supports us by subscribing to the channel and becoming a member, and who helps our project grow. I hope that over time, this will influence the fact that more and more people will be interested in science, and I would appreciate it if you would join us in this endeavor.